Welcome, everyone. I'm excited to kick off our presentation today. The topic is geometry, lines and angles. We'll explore the fundamental concepts behind lines and angles and see how they work together in various shapes and spaces. So, get ready for an engaging and insightful journey into the world of geometry. Let's get started. Let's take a look at the contents we're going to cover today. We'll start with basic terms and definitions, which are essential for understanding all kinds of angles. Then, we'll explore different types of angles, such as right, acute, obtuse, and straight angles. We'll see real-life examples of each to help visualize these concepts. We'll also discuss related concepts like adjacent angles, linear pairs, and vertically opposite angles. These are angles that have special relationships with each other. Additionally, we'll cover the ideas of complementary and supplementary angles, which are important when adding angles together. Throughout this presentation, you'll see how these foundational concepts connect to form the basis of understanding more complex geometric ideas. So, let's move forward and dive into each of these topics in more detail, starting with what we mean by a right angle and how it fits into the bigger picture of angles. Let's start by talking about what a line is. A line is a straight path that extends infinitely in both directions, meaning it has no endpoints. Imagine drawing a straight line that just keeps going and going without stopping. That's what a line is. Next, we have angles. An angle is formed when two rays share a common endpoint, which we call the vertex of the angle. Think of it like the corner of a room or the point where two roads meet. The size or measure of an angle tells us how much one ray has been rotated to align with the other. We can actually measure this rotation by considering the amount of circular arc that would be swept out as one ray rotates around the vertex to meet the other. Moving on, a line segment is a part of a line that has two specific endpoints. It includes all the points between those endpoints. Picture a piece of string stretched between 2 points. That's essentially a line segment. It's finite, unlike a line which extends endlessly. Finally, let's look at a ray. A ray starts at one endpoint and continues infinitely in one direction. Think of it like a flashlight beam that begins at a certain point and shines outward without end in that direction. It's important to distinguish a ray from a line segment because the ray has a starting point but no endpoint on the other side. Understanding these fundamental terms, lines, angles, line segments, and rays, helps us build a solid foundation for studying more complex geometric concepts. Let's explore the different types of angles that we encounter in geometry. First up is the acute angle, which is an angle less than 90 degrees. These are sharp and small. Next, we have the straight angle, which is exactly 180 degrees, forming a straight line. Moving on, an adjacent angle refers to two angles that share a common side and a common vertex, kind of like neighbors. A right angle is exactly 90 degrees, forming the corner of a square or rectangle. When two angles add up to 90 degrees, we call them complementary angles. They are like a perfect team that completes each other. Now, a linear pair of angles consists of two adjacent angles that are supplementary, meaning they sum to 180 degrees, and they form a straight line together. An obtuse angle is greater than 90 degrees, but less than 180 degrees, so it's a wider, more open angle. Speaking of supplementary angles, those are two angles that add up to 180 degrees, but don't necessarily have to be adjacent. Lastly, vertically opposite angles are the pairs of angles that are formed when two lines intersect. These angles are equal to each other and are often called vertical angles. Understanding these different types helps us see how angles relate to each other and supports us in solving geometric problems more confidently. Let's talk about acute angles. An acute angle is an angle that measures less than 90 degrees, which is also less than pi/2 radians. Essentially, these are the angles that are sharper and narrower. They're quite common in various geometric shapes and real-world objects. Remember, if you see an angle that's smaller than a right angle, it's an acute angle. Recognizing these angles helps us understand the structure and properties of different shapes. So, in summary, anytime you see an angle measuring between 0 and 90 degrees, you're dealing with an acute angle. Now, let's move on to the concept of a right angle. A right angle is formed when two straight lines intersect perpendicularly, meaning they meet at a perfect 90 degrees. This is one of the most fundamental angles in geometry because it represents a perfect corner or a perfect turn. When you see two lines crossing and creating this kind of angle, you know it's a right angle. Recognizing right angles helps us understand shapes, structures, and how different parts fit together in both math and real-world applications. Remember, the key point here is that a right angle is always exactly 90 degrees, making it a very important concept to master as we explore more complex geometry topics. Let's take a look at some real-life examples of right angles. As you can see, right angles are everywhere around us. For instance, the corners of a room form perfect right angles. When you look at a standard piece of paper, the four corners are all right angles as well. Even the corners of a book or a smartphone screen often have right angles. These examples help us understand that right angles are not just a mathematical concept. They are a fundamental part of the structures and objects we interact with daily. Recognizing these right angles in the world around us reinforces their importance and helps us see geometry in a new light. Now, let's move on to the next type of angle, the obtuse angle. An obtuse angle is one that measures greater than 90 degrees, but less than 180 degrees. So, imagine an angle that's wider than a right angle but not quite a straight line. These angles are important because they show us a different range of angles that aren't sharp or narrow, but rather more open. Understanding obtuse angles helps us see the full spectrum of angles in geometry, and they appear frequently in various shapes and real-world objects. So, keeping in mind that an obtuse angle is between 90 and 180 degrees really expands our understanding of how angles work. Let's look at some examples of obtuse angles. These are angles that are greater than 90 degrees, but less than 180 degrees. You can see here that they look wider than right angles. It's important to recognize obtuse angles because they often appear in various shapes and real-world objects. Understanding these angles helps us better grasp the overall concept of angles and their properties. As we continue, keep in mind how these larger angles differ from acute and right angles, adding to our overall understanding of geometry. A straight angle is a fascinating concept because it represents a complete reversal in direction. When an angle is straight, it essentially points exactly the opposite way from where it started. Visually, it looks like a straight line, which makes it quite easy to recognize. This type of angle measures exactly 180 degrees, which is half of a full revolution or two right angles. Understanding straight angles helps us see how angles can change direction completely, and it ties into the overall theme of how angles describe different kinds of turns and rotations. It's a fundamental building block in understanding more complex geometric shapes and angles. Now, let's look at some examples of straight angles. A straight angle is exactly 180 degrees, which means it forms a straight line. You might recognize this in everyday life when you see a flat horizon or a perfectly straight road. These angles are important because they help us understand when two lines are opposite each other in a straight line. Recognizing straight angles can also help us identify when an angle has been extended or straightened out. As we continue, keep in mind how these angles are fundamental building blocks in geometry, connecting concepts like lines, shapes, and their properties. Now, let's talk about complementary angles. When the sum of the measures of two angles equals 90 degrees, we call those angles complementary angles. It's a pretty neat concept because it helps us understand how angles work together in various geometric situations. Think of it like two pieces of a puzzle fitting together perfectly to make a right angle. This idea is important because it connects directly to right angles and other angle relationships we'll explore later. Remember, the key point here is that the total measure of these two angles adds up to exactly 90 degrees, making them complementary. This concept is a building block for understanding more complex angle relationships as we progress through this presentation. Now, let's talk about supplementary angles. When two angles add up to 180 degrees, we call them supplementary angles. This means that if you measure one angle and then measure the other, their total will always be 180 degrees. It's a key concept because it relates to how angles work together in various geometric shapes and configurations. Understanding supplementary angles helps us identify and analyze angles in many real-world and geometric contexts. Remember, the most important thing is that their measures sum to 180 degrees, which makes them a special pair to recognize. This concept ties into the larger theme of how angles relate and interact within different geometric figures. Now let's turn our attention to adjacent angles. In geometry, these are angles that share a common ray, which means they originate from the same vertex. Think of it like two angles sitting next to each other, with one side being shared. The key idea here is that their sides are side by side, or adjacent, hence the name. This shared ray is what connects them and defines their relationship. Understanding adjacent angles helps us see how angles can be positioned relative to each other, which is fundamental when exploring more complex geometric concepts. So remember, adjacent angles are always side by side, sharing a common side and vertex. Let's talk about the linear pair of angles. Imagine two lines crossing each other. Where they intersect, they form angles that sit right next to each other, sharing a common arm. These are what we call adjacent angles. When these angles are formed by intersecting lines and share a common side, they are called a linear pair. An important point to remember is that linear pairs of angles are supplementary, which means their measures add up to 180 degrees. Recognizing these pairs helps us understand the relationships between angles and is fundamental in solving many geometric problems. This concept ties into our overall theme of understanding how angles interact and relate to each other in different geometric configurations. Now let's talk about vertically opposite angles. These are a special kind of angle pairs that occur when two lines intersect. The key thing to remember is that these angles are formed from the same two lines crossing each other, and importantly, they are not next to each other. They all share a common point, which we call the vertex. What makes these angles interesting is that they are always equal in measure. This means if one of them measures, say, 50 degrees, the one directly across from it will also be 50 degrees. We call such angles congruent because they have the same size. Understanding vertically opposite angles helps us see symmetry in intersecting lines and can be very useful in solving geometric problems. It's a fundamental concept that ties into our overall study of angles and their relationships, emphasizing how certain angles maintain their measures even when lines cross.